bar notation. Don't think both are same. Both represents the different directions, opposite directions. Right? So here BA bar is nothing but x1 minus x2 into x plus y1 minus y2 into ay plus z1 minus z2 into a. I repeat again and again. It's not compulsory to give all the three values. For example, he may give the values as 3, 3, 2. Then what does the z value represents it as? 0. If he has given some value along x, that is the value of x. If he has given some value along y, that is the value of y. If z value is not given, then we have to assume it as 0. Why? Because in the coming problems, you may get such type of questions. If any value is given, you consider that as the value of the corresponding coordinate system. If the value is not given, just blindly consider that value along that coordinate system as 0. For example, if I give b bar is equal to x plus y, if I give b bar is equal to, actually here what I had given, b bar is equal to x2 ax plus y2 ay plus z2 az. Suppose if I give the value as x2 plus y2, and x2 1 into x2, what is the magnitude of x2? 1. What is the magnitude of y2? 1. Then what about z? If I not give 0, so you'll be getting such type of doubts in the problems. So blindly you can take the given values on the values that which is not given, you can take it as 0. We have one problem corresponding to that. We'll be doing it now itself. So here if it is 0, 0, 0, so 0 means starting at O and ending at A bar. So such vectors, position vectors can be also called as A bar. If it is starting at one point 0 and ending at another point, either we can call it as OA bar or we can call it as A bar. Why we are calling it as A bar? Why? Because starting point is what? Origin. Yes. Starting point is origin. But I cannot call this the above. But I cannot call this. Okay, good. Most of the people are answering in the chat. Good. But here I cannot call this AB bar as A bar vector. I cannot call this this AB bar as A bar vector. Why? Because A position is not 0 or B position is not 0 values. A has some value x, y, z. B has some value x, x2, y2, z2. So due to that reason, I cannot call it as only A bar or only B bar. When I can call it as only A bar or only B bar?
Full question appeared, sir.
Yeah, right. Okay, right. Answer this one. Have you finished? You got only one question or two questions, Sama?
Only one question.
Okay. Finish?
Finish.
Yeah. By next week, I will share the syllabus copy and the notes what I had prepared and what I have with everything with you through Canvas. Actually, we are waiting for all the people to accept the Canvas of ADC. Once if all the people are accepted that ADC, I will copy that email IDs and I will share everything to you, whatever I had with me. You no need to worry about that. Even short questions, long questions, even some videos if I have anything else, my videos or something very good. I will share it by next week, Amma. You no need to worry about that. Even if possible, I'll send my written notes also wherever you require. Okay. As we get second poll question, you just remind me. I'll give break for you for 2 minutes.
Yes, sir.
Yes, sir.
Okay. Okay, please mute. Please mute. So here, so this represents A bar. A bar can be represented if it is starting at origin. If it's O and B, then we can call it as B bar. If it is O and C, then we can call it as C bar vector. Suppose if A has the positions of X, Y, Z, X1, Y1, Z1. If B has the positions of X2, Y2, Z2, X2, Y2, Z2, then AB bar represents what? A as the starting point and B as the end point. First one will be the start point, then B bar will be the end point. End minus starting point. So just like X2 minus X1 into X plus Y2 minus Y1 into AY plus Z2 minus Z1 into AZ. Then if I take it as BA bar, first one will be the starting point, B represents the starting point, A represents the end point. Then starting point B is nothing but, what is the notations of B? X1 minus X2, Y2 minus Y1, right? So here, there is, how do you find the magnitude? How do you find the magnitude of AB bar? For example, if you see this AB bar, magnitude of AB bar is what? Under root of square of the magnitudes of X value, Y value, and Z value. So AB bar and BA bar, that is the answers. In the last class, we were discussing something about vector additions and vector subtractions. On that day, I had made you some logical analysis, but here I had made some diagrammatical point of view to understand clearly. So this is the vector of O and A bar, O and B bar. So both are separate vectors. If both are joined at O, so this is the starting point, ending point, starting point and ending point. So this is the starting point of OA bar and ending point of OA bar. This is the starting point of OB bar and this is the ending point of OB bar. Then what will be the resultant in between A and B? Right? So what is the end point of B? Starting point or ending point? In the diagram. End point of B is starting point or ending point?
Ending.
B.
Starting point.
Starting point.
A.
End point.
So the resultant is addition. So the resultant is vector addition. Right? Are you able to get it or not? So the resultant vector is C bar, or we can call it as AB bar. Even we can call it as AB bar also. AB bar, that can be called as C bar. That is equal to A bar plus B bar, or that is equal to AB bar. So when we are going to add the two vectors, if the resultant of the two vectors are of two different positions or same positions, two different positions,
Different positions.
then that is the resultant. For example, if you see the subtraction, for example, if OA bar, OA is the A bar. Why? Because starting at O. O is nothing but origin. Amma. You can barely take it as if it is represented as O, that is nothing but the origin only. Mostly, if it is not origin, he will represent it. He will make it in your writing that O is not an origin. Then OB represents B bar. If I join both at the origin, this is OB bar vector, OB B bar vector, OA A bar vector, right? Then what will be the resultant of this between A and B? Endpoints of A and B. What is the endpoints of A and B? Same endpoints or different endpoints? A, same
Same
endpoint.
endpoints.
So the resultant of these two vectors is subtraction of one vector on the other. Are you able to get it? So
Yeah.
if the direction is from A to B, it becomes B bar minus A bar. If you take the direction from B to A, then the resultant is A bar minus B bar. Mute. Okay. So I think now can you analyze when do we go for the addition of the vectors? Then when do we go for the subtraction of the vectors?
Yes, sir.
If the resultant of the two vectors, somebody please. If the resultant of the two vectors is same endpoints, either starting point or ending point, whatever it may be, then it is subtraction. If the resultant of the two vectors is of different endpoints, one vector different point, other vector the different point, either starting point or ending point, or head and tail, whatever you can call it as the words, then that resultant is what? Addition. So this is how we will go for vector addition and vector subtraction in the coming classes. Right? So keep it in mind. This is the final analysis. How do we go for addition and subtraction? Any doubt in this? No. Okay. So suppose any vector can be represented as in Cartesian coordinate system. A bar is equal to AX into AX bar plus AY into AY bar plus AZ into AZ bar. Ante if you take Cartesian coordinate system, it has three components, X, Y, and Z. So component of X of A vector is AX. Component of Y of A vector is AY. Component of Z of A vector is AZ. So A bar is equal to AX, AX bar plus AY bar plus AZ, AZ bar. Then what is the modulus of this vector? Under root of magnitude. The value before the unit vector is its magnitude. The value before the unit vector is its magnitude. So under root of AX square plus AY square plus AZ square. Right? So this is how do you find the magnitude of any vector? How do you find the magnitude of any vector? If anyone asks the question, sir, what is the component of A bar vector along Z axis? What is the component of A bar vector along Z axis? Means AZ. Component means its magnitude. Here I had given it as AZ, but even I can take it as some values. 3AX plus 5AY plus 8AZ. Sir, what is the component of A bar along Z axis? 8. 8. If it is 8, it is 8. Component means the magnitude of that vector along that direction. If anyone asks the question, sir, what is the component of A bar along X axis? It's the magnitude. If any value is there, that value is the component of A bar along X axis. Component means its value. Component means its value. Right? So here, this is the procedure. This is the procedure. So to find the magnitude from the vector. So if B bar is another vector is there, if B bar another vector is there, B bar is equal to BX AX bar plus BY AY bar plus BZ AZ bar. So what is the magnitude of B bar? Under root of BX square plus BY square plus BZ square. Suppose, have you got two questions, some poll questions?
Yes, sir.
Two.
Yes, sir.
Okay.
Yes, sir.
Right. Okay. So here AB bar. So suppose if A bar plus B bar, can you say I had written only the product of two vectors. If I ask the question, if A bar plus B bar, What do you mean by A bar plus B bar? Any one of you can you say this? Addition of two vectors. A bar plus B bar. AX. What is A bar here given? AX bar plus AY plus AZ. So add the component of X values. A bar plus B bar is equal to AX plus BX. So actually, I had given one question. AX plus BX into AX plus AY plus BY into AY. Addition means just add the magnitudes directly. X magnitude with X magnitude, Y magnitude with Y magnitude, Z magnitude with Z magnitude. If it is plus A bar plus B bar. If it is A bar minus B bar, just subtract the values, right? Then what is the values of A B bar? End point minus starting point, single vector. End point minus starting point. So BX minus AX into AX bar plus BY minus AY into AY bar plus BZ minus AZ into AZ bar. So how do you get the magnitude of AB bar? Till now we have seen the magnitudes of A bar and magnitude of B bar only. Then how do you get the magnitudes of AB bar here? Same thing. Under root of magnitude of square of magnitude of X component. What is the magnitude of X component? BX minus AX. So under root of BX minus AX whole square plus BY minus AY whole square plus BZ minus AZ whole square. This is how do you find the vector values and the magnitudes of a single vector or the two vectors. Two vectors means the vector starting from origin or the vector starting from one point to other point. So this is the analysis, right? Suppose if X, Y, Z values are not given, so only position vectors are represented as R and R1. R bar, R1 bar. They are starting at zero and ending somewhere else. So one vector is given as R bar, other vector is given by R1 bar. This R bar and R1 bar is nothing but the resultant value of one vector, other vector. So both are ending with same endpoints or different endpoints?
Same endpoint.
Same endpoint. So resultant will be addition or subtraction?
Subtraction.
So resultant is noted by R bar. So R bar is equal to R1 bar minus R bar or R bar minus R1 bar, depending upon the direction. Bottom to top or top to bottom. Suppose if coordinate values are not given. Suppose if coordinate values are not given, if only position vectors are represented directly. Please keep it in mind. Again, I am repeating this. This is very, 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 very important. Very, very important. Even in GATE exams also, you'll get the questions like this. At least one question, 2 marks question, depending upon this vectors, dot product, cross product, or the component of any vector, something like that. When GATE and IES and in any competitive exams, definitely for EMTL, you will get 10 to 15 questions, marks of questions. So please, if you are very much perfect in the basics, at least you can read the question. If you are able to read the question, means you can solve it. That's not a problem. Most of the people has a fear that they will not even read the question of EMTL. Why? Because they are very much not funda in the basics. These are simple now. Even a simple question also, just by seeing that, okay, this is related to EMTL. I will not touch it. But that is a false statement. That's a bad habit. So these are the basics. What I thought it is more useful for you people, for the students, so such that you can use everywhere directly without hesitation. So till now we studied about representation of the coordinate systems at this point and this point. And here instead of coordinate systems, if it is represented in the position vector form as R bar and R1 bar, whatever it may be, I want the vector value. So here one vector is represented as R bar, other vector is represented as R1 bar. Then the resultant is noted as capital R bar, for example. Resultant you can take it by any value, but as an analysis, but as our procedure, but as our habit, we always represent the distance in terms of R. We always represent the distance in terms of R. Due to that reason, capital R is taken as the resultant value and small r is represented by the position vector distances. Just by habit, distance R or the radius R. right? If it is, for example, A bar, instead of R bar, it is given as A bar. Instead of R1 bar, it is written as B bar. Okay, no, fine, well and good. You can take it. That's there is no objection in that. So what will be the resultant of R bar, capital R bar? A bar minus B bar, or B bar minus A bar. If the position is from top to bottom, bottom to top. Then how do we get the magnitude of this? R bar is equal to R1 minus R1 bar minus R bar whole square. Anything. This is the vector value. Some answer, some value. So under root of square of that resultant answer is nothing but the magnitude of the resultant. Right? Any doubt in this? Why? Because next we are going to do one problem, Amma. If you have more clarity about this, then I think you can answer this. Any doubts? We have only 10 minutes more. Shall I give one question? Yeah, even the question is visible. All of you write this question. All of you take the pen and paper and write this question and post these answers in the chat box. If A is equal to 10x minus 4ay plus 6az, and all of you listen here, Amma. Okay, nisham. B is equal to 2ax plus ay. Here the z component is not given. What do you mean by this?
Z equals to 0.
0, right? Good. Very good. Excellent. So here z is not given means it represents 0 value only. First one, I got only one person has given me the answer. Only one person has given me the answer. 2, 3. I want, how many are present now? 147. I want at least 147 answers. But excellent, Amma. Very good. Even with this online classes also, almost all the people are giving me the correct answers. Whatever we expected in the classroom, same thing. Oh, everyone is giving a very good correct answer, at least for the first option. Is this chat box visible to everyone? So one has given 35.735. Okay, good. 35.73. 35.73. At least I'm getting some multiple answers. So here, what is the first option, Amma? What is the first component? The component of A, capital letter always represents vector. Capital alphabet always represents vector. So component of A means what does it give the meaning? Component of A means what does it give the meaning? About vector. A vector. A vector along which direction? X-axis or Y-axis or Z-axis? X or Y or Z, Amma?
Y.
Y. So if you see the A vector, A is nothing but 10x, means the component of A vector along X is how much? Component means magnitude. Component means 10. But here we asked about X or Y? Y.
Y.
So the answer is minus 4. Component means magnitude. Component means magnitude. Magnitude of unit vector ay of a vector. Magnitude of a vectors along ay direction, along y direction. So the answer is minus 4, Amma. What is the component of A along z axis?
6.
What is the component of B along z axis?
0.
0.
Right. Good, very good. What is the component of B along x axis?
2.
So I think by today's class you can say what is the scalar value, what is the vector form, what is the position vector, what is the distance vector, dot product, cross product, addition of vectors, subtraction of the vectors. Then if vectors are given directly as r bar, r1 bar, I think you can get the answer. Yes. Mute. Yeah. So I think this is what you have studied in this today's class. Almost all the people has given the answers except some. Okay, the 35.75 is second answer, I think so. Okay, good. Okay, very good, Amma. So then what about the second answer? Even I had the solution for you also in the next slide, but I think this solution is not required for you. Why? Because all the people are doing it perfectly. Then do the second one. So the second one is easy. The magnitude of 3a minus b. What is 3a?
30
Multiply.
minus
Right.
plus
Good.
8.
Good. So multiply the vector a with 3. Means 3 into 10ax 30x minus 3 into 4ax 12ay plus 6 into az 3 into 6 into az అంటే 18ax 30x minus 12ay plus 18az minus b. So b is as it is. So what is the answer for that?
28ax
13ay
Okay.
plus 18az.
But do you require the resultant of 3a minus b, the resultant vector of 3a minus b, or magnitude of that? Magnitude. So that point is more important. So here we require the magnitude. Then how do we get the magnitude?
Square
By under root of
Square root of the component.
28a square plus 13a square.
Plus
Under
13
root of
minus 13.
minus
30.
Okay. Plus 18. Even you even had given my answer also. So the first one, the component of a is along ay, that is ay is equal to minus 4. Second one is 3a minus b, that is equal to 3 into 10ax minus 4ay plus 6az minus 2ax plus ay. So 30 minus 12 plus 18 minus 2ax plus ay. So 30 minus 2 plus minus 12 minus 1. So z is not there, so we will take it as 0. Plus 18 minus 0 is z bar. So the resultant is 3a minus b is equal to 462. 28ax minus 13ay plus 18az. Right? But we want magnitude. So we have to see each and every word what is present there. The notation and the representation is more important, Amma. Then I think what about the third one? Third one, I think it requires some analysis. If we do the third one, then I think I can accept you that you understood about everything about the vectors, unit vectors, scalars, and all those things. Third one. What is third one? Third question.
Unit vector along a plus 2b.
2b. First, we have to find a plus 2b.
Yes, sir.
A is as it is. What is a?
10ax minus 4ay plus 6a.
Yeah. Okay. Then what will be 2b?
4ax plus
4ax plus 2ay.
2ay. Right. Find the resultant of that. First, to find the resultant vector analysis of 4a a plus 2b.
14ax minus
10ax
plus
minus 2ay plus 6a.
Plus 2a.
So that is the resultant vector of a plus 2b. But what we require?
unit vector.
Unit vector.
Unit vector. Unit vector of what is the definition of unit vector? Definition of a unit vector of a. What is the definition of unit vector of a? A bar by modulus
A
of
bar
a.
by modulus of a.
A. For what is the unit vector of AB bar?
AB bar by modulus of AB bar.
AB bar. Fine. What is the unit vector of A plus 2B?
A plus 2b by modulus of a
A.
plus 2b.
2B. Right. Good. Then do this analysis. Any one of you got the answer? If you get the answer, you can post in the chat box. So, right.